Hi guys, this is Team Vitalize and here is a demo. So, what our project does, let's have a quick recap. Whenever an emergency vehicle approaches a car, then the array of microphones at the tail end of the car record the siren and they play certain 3D audio spatial sounds inside the car which alerts the driver as to where that sound is coming from, and according to that sound or direction of the emergency vehicle where the driver should ideally move to in order to avoid that emergency vehicle. So the development process, well, let me guide you through it. The entire prototype of the code was initially developed, and that used to play only one sound, which was only the sound which indicated the vehicle that was incoming. Then we did a user study and we designed another sounds because the initial sound was a bit alerting and it wasn't as pleasant as we expected it to be. So the code was restructured and modified. I added a few features, the entire group added another features, and then a second set of testing was done, which included two set of sounds. One that was with for the emergency vehicle, the incoming emergency vehicle, and the second sound was the direction in which the driver should go after the entire emergency vehicle recording has been complete. For the demo, we actually tried. What we did was we played audio from the MATLAB program, but we weren't able to get the exact output from the Citrix receiver. And what we did was we took out audio samples and we made multiple audio samples of an emergency vehicle at different directions and at various different angles. And what we did was we played them in a car. We initially wanted to try it out at the University of Florida Computer Science Automotive Simulator, but due to some issues we were unable to get access to it. So we tried it in one of our cars and it played perfectly. We were able to hear the distance as well as the direction of the audio in the car. Here is an example. So as you can see, those sounds vary in the distance they have from the recording device in terms of direction as well as, well, distance obviously, and that's what we did. So this here was our first user study where people did not find the sound pleasant, and the sound we used was this. And for the second user study, the sound that we used was this one. So when talking about the project, it's actually really important to have national agencies and institutions use it, and that is the primary focus of it. It can be used by American Traffic Safety Services, it can be used by the National Highway Authority of India, and other agencies which help provide safety to people on the road. Then the system is actually easy to implement. So each of the cars that we have available today already have a computer built into it. So all we need to do, the one additional component that is required, is the need for microphones that need to be fitted at the rear end of the car. And this particular system, once it's developed on a cross-platform basis, can be very easily implemented. Like I said, we were unable to access the UF driving simulator. So if we had an additional semester, we'd definitely work with the driving simulator. Other than that, we'd actually research with the siren sounds that we have. We'd research with the microphones. And we'll also figure out the best way that would allow users to get this information in the most least annoying way. Well, if we had all the time in the world, then we'd actually put everything on a real car. We'll implement the microphones, we'd create a cross-platform version of MATLAB program. We'd also improve the algorithm if, as it turns out, there might be some gaps in it, or if there's any issue with how the users listen to it, because each user might have a different HRTF which might need to be implemented in the system itself. Other than that, we would definitely compile a database of various different sirens that would help us identify what siren is playing behind the vehicle, and we could tell the user about that information appropriately. So the challenges that we expected was about the UF driving simulator, which we did not quite experience. And well, obviously during COVID, the testing isn't easy. So we tried our best, and we got like 7 to 8 people for our second study, whereas we got 5 for the first one. Also, the challenge of the sound was that the sound needed to be melodious, but it should represent urgency and not just something that's music. And it needed to be a sound that does not distract the driver. Also, the main issue was to get a high accuracy, because cars aren't really designed from an audio perspective in mind. They are actually designed from a security perspective, and this was a major challenge to get accuracy about the direction and the distance of the ambulance that we needed. Some unanticipated challenges were to create an algorithm that would actually isolate the sound of the sirens, which is still an open research project at this point, and the difficulty of compiling all the sirens that exist, and to use a software or design a software that works like Shazam does, and it recognizes the sounds of music, or in our case sirens, from all of the noise around it, and still give us an appropriate output. And well, we couldn't really coordinate with the driving simulator lab because of a tight project timeline. Well, here we are. This is the team, and I thank you all for being kind listeners. Thank you.